welcome to my kitchen. Today I'm going to attempt to make something that is really vital for the Webb telescope's ability to see. So let's give it a go. But first I have to make some distilled water. You see that? Alright, cool. Let's get it done in the kitchen. It's a salt crystal. Who doesn't love salt? It has a long and important history. Since it was once the only way to preserve food, it also dictated trade routes. It was one of the most coveted and expensive minerals. Today, we rely heavily on salt to keep our roads safe, and salty snacks are the best. Webb needs salt. Not this tasty kind, but as a lens. So there are different types of lenses. Mirrors are a reflective lens that bend the light. And then there are transmissive lenses that allow light to pass through them. Here's the kicker. Visible light, it behaves differently than infrared light. So glass absorbs infrared light, but salt doesn't. The type of salt in here is sodium chloride, or NaCl, and even though it's the most common type of salt on Earth, it is not the only kind. Salts are more than something you sprinkle on your food. A salt is a combination of two things: a positively charged element, usually a metal, from groups 1 or 2, and a negatively charged halide, usually from groups 16 or 17. They get their charge by either gaining or losing a negatively charged electron. So Webb uses 3 kinds of salt lenses: lithium fluoride, barium fluoride, and zinc selenide. So making these lenses happens to be pretty tricky. I've been growing this one now for about 3 weeks, and it's only this size right here. The lithium fluoride lenses that Webb uses have to be absolutely perfectly grown. So to be optically useful, it needs to be completely clear, unlike my homegrown little crystal over here, and be molecularly consistent. That means that the structure of the molecules are absolutely the same everywhere. Then they have to be cut, and then they have to be polished. Considering what these lenses will do, they are sure worth their weight in salt.